Let's go.
Hello, I warmly welcome you to our 79th webinar by the Academy of Space Renaissance International. My name is Sabine Heinz, and I'm the person responsible for our webinar series. And on this 14th of April 2025, I'm really delighted that you have come to join us. I would like to ask you to write in the chat where you are watching from. And I would like to welcome our today's special guest. It's Dr. Eligar Sadeh. Hello, welcome.
Hello.
And it's really a pleasure for us to have you here. And Eligar will speak today about astropolitics, the human relationship to the space and enterprise. And I also would like to welcome Professor Bernard Foink. He is our president. Hello,
So,
Bernard.
hello. So, yes, welcome on behalf of Space Renaissance International. Yes, I've met Dr. Eligar Sadeh at various occasions. I even met his father. His father, Dr. Sadeh, at the first ISC conference I organized in Washington, D.C., and his father was speaking about inflatable structure on the moon, you remember? And then I was so amazed to meet Eligar later and on some of his achievements. So I'm looking forward also to hear about some of the astropolitics, geopolitics aspect, and how this is also getting along our vision towards space exploration. So welcome, Eligar.
Thank you. Thank you. Appreciate that, Bernard.
Thank you, Bernard. And you asked him, or you reserved already a space habitat for you, an inflatable space habitat for the moon?
Yes, this was the father. He was from, I remember, Colorado University, if I remember well. And he made big effect at that time. And we also developed some concept of habitat using inflatable. And now, both in space and also for future moon, this is something which is very much part of the architecture of future moon base.
Yeah. Okay, thank you. And I also would like to welcome Adriano Ottino. He is also one of our vice presidents and co-founder of Space Renaissance International, and he is former president of SRI. Eligar, before I leave you the floor, I would like to introduce you to our audience. So yeah, Adriano, hello. I'm sorry.
Okay, never mind.
Um, Dr. Eligar Sadeh is an aerospace professional since 1982 and the man who wrote the book on the human relationship to the space enterprise. He is a TEDx speaker and CEO and founder of Astroconsulting International Limited Corporation and the non-profit Astropolitics Institute, where he engages in technical consulting and educational programming. Ellie serves as chief editor of the academic journal Astropolitics, which covers human factors related to the space program. He's a professor and STEM educator of aerospace engineering, space operations, program, project management, business and entrepreneurship, astrophysics, physics, environmental studies, and astropolitics. Professional experiences include work with NASA, Lockheed Martin, SpaceX, Embry Riddle Aeronautical University, University of Colorado, Colorado State University, U.S. Air Force Academy Eisenhower Center of Space and Defense Studies, U.S. Air Force Space Command, University of North Dakota Aerospace Sciences and Space Studies, International Space University, and foreign national space agency and academic institutions. Eligar Sadeh is working to develop expeditionary STEAM programs, and Eligar's leadership in aerospace and seminal publications helped revolutionize the way we think about space exploration and the space program. Eligar, the floor is yours.
Thank you. Appreciate that. Yeah, thank you as well, Adriano, and appreciate the invite before the Space Renaissance Group. Always a pleasure to address people who are interested in this topic on the what I call the non-scientific, non-engineering, the space enterprise, which is just as important, right? It's the more human-centered part of what we do. You know, the politics, the economics, the laws, you know, the environmental aspects, management, organizations, and even the philosophical, emotional, spiritual aspects of what we're doing in the space enterprise. Thank you as well, Bernard, for the kind words. It's been a while since, you know, we've interacted. I know we've interacted for a number of years, and I was involved for a while with the International Lunar Exploration Working Group, and that was a pleasure to work with you there. And thank you for the kind words on my late father. Yeah, he was a pioneer and kind of the civil engineering side of the space enterprise, and did some interesting work, as Bernard mentioned, on inflatable habitats on the lunar surface, which was some of his pioneering work he was engaged with. You know, I miss him dearly, worked with him until he passed away, but that's quite a while ago at this point. But thank you for the kind words. I appreciate that. So I wanted to discuss today, there'll be a couple of things I'll discuss. I wanted to first give a talk that kind of looks at, you know, emotional, spiritual, and then some scientific and other aspects related to, you know, this whole area of astropolitics that I've broadly defined as kind of the human relationship to the space enterprise, or human dimensions of the space enterprise. And this first talk is kind of drawn from my TED talk that I gave a couple of years ago, kind of looking at the spacefaring revolution and the future of us on this planet, you know, the future of planet Earth, with a focus there being more human-centric, you know, not to disregard the environment or other biological life, but the idea being is how does the space revolution play into the future of the human species on planet Earth, and what is the connection between the two? So I don't have too many slides in this presentation, but I'll let me pull up my everybody can see that slide?
Yeah.
Okay.
Yes, we can.
Yeah. And this right here, just, and then I'll go into the talk, is, you know, some of you, probably many of you are familiar with this image, and maybe not all of you, but it's from the Hubble Deep Field View. They decided to do an experiment when the Hubble was up and operating after the space shuttle launched to fix the lens issue on the Hubble. And they did a Hubble Deep Field View experiment, and they did a couple of these where they pointed at a dark spot into the cosmos to see what they would find, and they found images like this. You know, every image you're seeing in here is a galaxy, and this began to fundamentally transform our sense of the expanse of the cosmos. You know, we're talking about trillions and trillions of galaxies, and the universe has expanded so much over time, over its 14 billion year history or so, a light year history, that you know, there's a horizon to which we can even see the universe. You know, we can't even travel to most of the universe. It's untravelable even at the speed of light. So it just gives you a sense of the vastness in the cosmos, of the cosmos itself. And that really just does tie into the talk. You know, in essence, what does outer space offer us as a human species? So I wanted to you know, start by, you know, discussing that we have an ongoing spacefaring revolution. And this really began with the rise of the space age in 1957 with the launch of the first Earth orbiting satellites. And I think we've continued on that evolutionary track since then. And particularly today, where we're seeing a revolution going on, thinking about space in a context of how it can better us as a human species, from a standpoint of being an observing platform back to planet Earth, and also extending outwards. Today we're talking about concepts of mining asteroids, mining the lunar surface. This can enable us to sustain ourselves in sustainable ways off Earth, but there's also a benefit back to Earth that I wanted to discuss today. And in addition to that, we're seeing, the enhanced, what I would call commercialization of the space enterprise on a private basis, where we have private entities today, commercial entities, that have the same capacity only reserved for governments in the past in partnership with their commercial partners. But today we're seeing private entities, kind of using SpaceX as an example, because that is usually symbolic of what's going on in this revolution in terms of a privatization of space activities, which is also accelerating in many, many unique ways the utilization aspect of our spacefaring enterprise. So to start with, I wanted just to engage in a thought experiment. And thought experiments can be very, very powerful. Thought experiments can really lead to fundamental change in how we view everything. If we're talking about astropolitics, we can engage in thought experiments of a future world based on cooperation and peaceful uses, as enshrined in the Outer Space Treaty of 1967 that the majority of states have subscribed to. Putting aside the conflict and competition and contesting of space that we also see going on, but we can envision peaceful ways, cooperative ways to pursue the space enterprise. And it can really be a powerful way, to think about the world, to think about paradigms and our thought structures. I think there's no better example than Albert Einstein, the great physicist Albert Einstein, who really used thought experiments that fundamentally changed our understanding of reality in many, many ways, particularly at the cosmic scale. Fundamentally, revolutionized our understanding of cosmological physics and processes that we're verifying today through the gathering of data. And he was able to do this through thought experiments and then justifying those thought experiments through mathematics. So I want to imagine that you're traveling in outer space, and before you appears planet Earth. We've seen this image many, many times in pictures on Earth. It's become an iconic image. But there's a different experience, a different sensation that arises, and it's a deeply emotional, spiritual, and even, I think, paradigm-changing perspective, if you really begin to think about it. And for those who've been privileged enough to travel off Earth into outer space, and that can include even the suborbital domain that we're seeing today emerging with some of the space tourism, space tourism focuses going on, and those traveling into Earth orbit, and the handful of humans that were able to travel to the lunar surface. This is an image that we see, and it can be, very, very powerful. And I want us to think about this, across three levels of analysis. And as I'm talking, you can also do kind of your own reflection in terms of what are the implications of this? What is the messaging that this image offers us at three levels? One being cosmological, the second being global, and the third being at an individual level. I think at the cosmological, we see the finiteness of the Earth located in the harshness of the space environment. Once we leave the Earth's atmosphere, we're no longer in the protective cocoon of planet Earth, and we're exposed to the harshness of space, space weather phenomena, space radiation, extreme temperature variations. And I think we get a sense of the fragility of our own biosphere in contrast to the harshness of planet Earth. And also, I think the finiteness of the planet itself. And I think we see that the Earth is embedded at the same time, while that is one aspect that we do see, another aspect is the way in which the Earth is embedded very much into what Einstein called the space-time fabric of the universe. We're integrated into the cosmos itself. In fact, the naturally occurring cycles on Earth, astronomical cycles, have dramatic effects on the warming and cooling of our planet. To put aside human-induced climate change that I'll get to later on, it's the Earth's elliptical inclination that varies over time, combined with the precession of the Earth and the way in which it wobbles as it's rotating, in combination with slight variations in the path around the sun, the elliptical path around the sun, that all map quite well with warming and cooling trends in the Earth's long-term climatic history. A Russian physicist by the name of Milankovitch was able to map these out, and they map very, very precisely with the data that scientists have acquired that show these long-term, over millions of years, these long-term cycles of global warming, including ice ages and warming periods over the Earth's climatic history. So I think it gives us a sense that we're intimately integrated, embedded into the cosmic domain, into the domain of the fabric of the universe, the space-time fabric of the universe. And we're fundamentally connected to that. And I think that's important to remember, that we are part of the cosmos. We are not separate from the cosmos itself. Shifting to the global level, I wanted to paraphrase one of the Apollo 8 astronauts. Apollo 8 was a mission that went into orbit around the moon to prove the capacity to land on the moon, which was later accomplished by the Apollo 11 mission. And one of the astronauts, as they got to the lunar orbit and went into orbit around the moon and came around the far side of the moon, because the moon is tidally locked to the Earth, so we only see one side of the moon visually. As they came into orbit around the dark side, what we call the dark side of the moon, or the far side of the moon, since it's tidally locked, and they witnessed the Earth rise across the lunar surface, one of the astronauts remarked, in the paraphrase him, "We came all this way only to explore and discover planet Earth." And what is the implication of this? What does this mean? The late Carl Sagan addressed this quite deeply as well in his book, Pale Blue Dot, that he wrote. Pale blue dot being an image of Earth from the further regions of our solar system, like from Jupiter or from Saturn as examples. Earth appears as a pale blue dot, a pale blue star in the night sky. But what does this suggest? This suggests that when we see this image of planet Earth in a holistic sense, there really is a one planet. It suggests that everything is interconnected. And I think science is beginning to move in that direction as well, where there's a deep state of interconnectedness between all of reality. And I think the image of the Earth from outer space, if we think about it at the global level, gives us this perspective of connectedness, this perspective of everything being integrated. And ultimately, this can have a fundamental shift on our insights, the way we view things. Because the dominant worldview right now is very much, if you look at whether it's mainstream science, applied science in a realm of technology, the way politics and economics tends to work, we see a disconnected worldview being the more dominant paradigm, and a connected worldview being less dominant. And I think this is this can be problematic, right? When we think about aspects of space that don't align with the principles of the Outer Space Treaty, right? Peaceful uses, space for the common benefit of mankind, where we're seeing space being used in ways that are contesting each other, in ways that are in conflict with each other. The military space domain, space being used as a platform for warfighting. It was just announced last week by the U.S. Space Force at the symposium that I attended in Colorado Springs, what's called the Space Symposium, that the U.S., although they don't desire a war in space, feels that the contested environment is in such a state today, particularly vis-a-vis countries like Russia and China in particular, that weapons in space are now justifiable. That results largely, I think, from a disconnected sense, right? A disconnected worldview. I think looking at the planet Earth from outer space can shift that perspective into a connected worldview, an integrated worldview. This has consequences because the more we think about connection and integration, the more then we're going to put aside conflict and we're going to solve our problems through peaceful means. We're going to cooperate more. We're going to recognize that we're all in this together on a finite ecosystem, on a finite biosphere, integrated into the cosmic fabric. And this can also allow us to better engage. And I think there's trends in this direction, right? I'm talking about dominant versus less dominant approaches. But this can allow us to accelerate at a much faster rate. And we're already seeing the trend in this direction of what I would call systemic thinking, holistic systemic thinking, which can be very, very profound. You know, we begin to unravel the complexity of the way things are connected. And this can be just as true in a scientific enterprise. And we're seeing that trend, I think, in that direction, as it can be in other areas, right? If we think about astropolitics and geopolitics, engaging in systemic thinking in a geopolitical sense implies we think strategically instead of thinking instead of thinking across tactics. We think at a higher level. We think about the global consequences of our action. We think about the global consequences of what would a contested space environment look like? What would space warfare look like? How would that serve or not serve humanity? So I begin, and it also implies a long-term thinking approach versus a short-term way of trying to address and solve problems. So I think it can fundamentally have consequences across the board, right? If we just think about science and politics as two areas, it can have fundamental changes in our paradigms and approaches as we begin to understand a connected worldview that emerges from the global level here by looking at planet Earth. At the individual level, it kind of reminds me, in the way I would think about it, is that we all are tied to certain narratives, and narratives define our experiences. You know, the way in which we interpret reality, the way in which we create stories to define our reality. And in fact, scientists, social scientists have recognized that the rise of the Homo sapiens as the more dominant species on planet Earth has been largely framed by narratives supported by a cognitive revolution. The idea is that our large brains have allowed for a cognitive revolution to occur in such a way that we can create ideas, myths, stories that define our reality, and then we can act on that in different ways, whether that's scientifically, politically, economically, socially, etc. And that's allowed that cognitive revolution framed by narratives to allow the human species to really become the dominant species on planet Earth. And these narratives really form our worldviews. In many ways, worldviews, whether it's scientifically or politically, are narratives that we tell ourselves, right? And these narratives have consequences. So it's something important to keep in mind. I think also one of the things that has been discussed in relationship to this image by the work of Frank White, you may have read his work or not. Frank White he's a social scientist, went about interviewing, at the time that he wrote his first book, I think it was in the 1980s or 90s, I can't remember the exact date right now. He went and interviewed all the astronauts who had flown in outer space. So astronauts, cosmonauts, worldwide. I'm not sure if he interviewed any of the Chinese, but what he found among all the astronauts who had flown outer space, either into orbit, and he even interviewed some of the Apollo astronauts and viewed this image from outer space, it all fundamentally changed their perspective. And it shifted their mindset, just broadly speaking, into the connected worldview that I had discussed earlier. And it was even described by some as an emotional, spiritual experience, very, very deeply felt. And I think this can have profound consequences, again, on how the human mind processes information, views the world, shifting that perspective again. We're talking about a paradigm shift in how we view everything, from disconnection to connection. And he used the term overview effect. Some of you, I'm sure most of you might be very familiar with this term. And that kind of encapsulates the overview effect. The idea is that you have this overwhelming sensation, and it was shared by all the astronauts. For some, it was maybe less emotional or more emotional, but they all experienced something similar at whatever level they experienced it, that we're all deeply connected one with the other. There's an integrated world view, there's a connected worldview that begins to emerge out of that. So with that, I wanted to shift and look at a couple additional aspects. One being science itself, the scientific enterprise, which underlies what we do in space, right? It all emerges from science. From science, we have applied science, which is essentially engineering, which develops technology, which underlies the space enterprise. But I want to kind of look at it from a very high level in terms of thinking about the ways in which emerging postulates, I would just call these postulates at this point, right? Tentative hypotheses at this point of shifting science, how there are scientists still working more on the margins of the scientific enterprise, but how science is beginning at least to move in a direction, I think, that will take it more to a connected worldview. And I think we're beginning to see more and more of this, particularly in the area of quantum physics specifically, and the whole search within the world of physics between, we know at a deep level, quantum and cosmic are connected. The connections are difficult, right? There's like concepts of quantum gravity. Einstein worked for a long time. Physicists generally call this the theory of everything. But there are some telltale signs, right, of quantum cosmic connections that scientists are beginning to get insight on. And I kind of wanted to discuss that from a level of postulates in terms of what could be called a unified scientific framework, and what would be the underlying postulates of that. If we were to talk about a unified scientific framework. Well, there would be four basic postulates to this. And this is kind of just drawn from trends that I see that are going on there, and different physicists that are working, again, still within the margins. They're kind of looking outside the existing paradigm that governs most of science and trying to think about it in a different way, that paradigm shift that I talked about earlier. And the first one is moving from a disconnected worldview to a unified worldview. The Ivy beings that I think we're beginning to understand from the world of astrophysics that the universe and all the matter and energy within the universe are a unified whole system. I think Einstein began to put us on that trend of thinking with his revolutionary insight of the fabric of the universe and the space-time fabric and the insights such as gravity, and gravity simply being a geometric phenomena that occurs as a result of the way in which space and time and matter and energy are integrated into the cosmic fabric. And this is different, I think, from the more dominant view that still seems to govern most of science, that the universe is reducible, right? We can reduce the universe to its individual parts and components, just like an engineer would reduce a system to its individual parts and components in order to build that system. Second postulate here would be, this is probably a more controversial one for, I think, a lot of mainstream scientists in the mainstream paradigm of intelligence versus randomness. There is this sense that I think among mainstream scientists that there are a random set of occurring phenomena that allows for processes that we observe, cosmological processes, to give an example, including the creation of planetary systems and planetary systems that can support life like the Earth. What counters that in terms of a more unified space framework is the idea that we need to add one more element into the fabric of the universe, and that is intelligence. And there is a thought among some scientists, again, more on the margins, that intelligence itself is embedded into the fabric of the universe, and that there's an intelligent process that occurs that allows for planetary systems to evolve and life to evolve, as an example. And if you begin to look at the way life is structured and the complexity of life, there is some evidence suggesting this could be a valid insight. And it would, I think it would dramatically change our paradigms as well if, there was a way to verify this in the scientific methodology of an intelligence being part of the cosmic fabric itself, that things just aren't randomly occurring events. That would also open up these possibilities of what we're already observing of possibly multiverses. There's some interesting evidence that suggests that may be plausible. Extrasolar planets in other solar systems. In the Milky Way alone, it's been extrapolated that there are up to 1 trillion planets just in the Milky Way galaxy. And thinking about life being random versus intelligence with the emerging number of habitable planets where intelligence life could evolve provides some interesting insights, I think, into thinking about this postulate. The third one is a balance versus a dissolution. The governing theory in physics is that of entropy, which is really dissolution, if you really think about it at a simpler level. I'm not going to go into the depths of science here. I'm not a professional physicist, but I have an engineering degree in my first degree, so I studied physics for several years as an engineer. But entropy is fundamentally about a decreasing order, right? Things move more in a direction of of randomness and dispersion in different ways, different dynamics, without going into details about it. The posture that would counter that is one of a harmonious balance between increasing and decreasing orders in a way in which ultimately matter and energy are dispersed. So again, that could have, that's an interesting postulate, right? That I think could have consequences. And again, I think you could begin to see the way if you think about a disconnected worldview, randomness and dissolution support that. If you begin to think about a connected worldview, integration, everything is connected, unified, intelligence, balance between decreasing and increasing dispersions of matter and energy, that would justify a connected worldview. And lastly, and this could have tremendous consequences, and there were different engineers and scientists who've shown some possibilities in this direction. There are people involved in rocket engines as well. I know there's a NASA team. I think there might be a European team. Tesla and some of his pioneering ideas and work also showed some interesting insights into this, that instead of viewing space itself as a vacuum, and a vacuum doesn't mean devoid of anything. Clearly, there's some matter and energy right within that vacuum, but instead of viewing it as a vacuum, the fabric of space itself is locked with an infinite energy potential. There are some scientists who think that this is actually locked at the Planck length, which is the shortest length that we can get to, 10 to the minus 30 something, I think 34, 35, if I remember the number correctly, meters. At the Planck length, there is an interlocked system where energy exists in abundance, infinite energy. And there's some interesting experiments that are going on suggesting there may be something to this, whether it's locked at the Planck length or locked within the vacuum itself at different quantum dimensions, that we have an abundance of energy. And I'll get to this point, I'll elaborate a little more on this point in terms of what that may mean for humanity and particularly for intelligent civilization. Right now, just to frame where I want to go next is that, I'm sure many of you have seen this image before, but this is data that NASA's Earth Science Program has gathered, looking back at about a million-year climatic history of the planet in terms of carbon dioxide, CO2, carbon dioxide within the Earth's atmosphere that underlies human-induced global climate change that we're seeing today since the rise of the industrial age around 150 years ago or so. And what we could see are the naturally occurring cycles of warming and cooling that have occurred over the history of the planet. And these, again, are linked to the astronomical causes that I mentioned earlier, as well as geological processes on planet Earth that occur in various forms, such as supervolcanic eruptions and other, processes. I'm not going to get into the details. There are geological processes that occur on planet Earth, combined with those astronomical processes. But we see here, moving to the right of the slide, how over the rise of the industrial age, we have exceeded the natural cap of the amount of carbon dioxide that exists within the Earth's atmosphere. And when we're talking about human-induced climate change, this is really I think this encapsulates it better than probably anything else, that we are exceeding the natural variability in the Earth's climatic ecological system. And what does that mean? Well, that has consequences, particularly from a shorter term climatic or geological perspective, right? It has consequences over the course of hundreds of years. Ultimately, natural processes may overwhelm this if we begin to project things out over 50,000 year cycles, 100,000 year cycles, as this graph suggests. But this does have consequences for the way in which we are living on this planet during this era emerging from the last ice age, as Holocene, the last ice age ending about 15 to 20,000 years ago, and the way we live on this planet and the way the current species live on this planet. This has consequences at least for several hundred, potentially several thousand years or longer in terms of our capacity and the current life forms that exist on this planet that have adapted to this environment to successfully survive within this environment. So this is important. Some people feel that we are entering an Anthropocene, what is called an anthropogenic-driven era in the Earth's climatic and ecological history. This could lead to a near-term, I think, many scientists are saying potentially within the next century or less, to, at some level, a global extinction event. So why is this occurring? What underlies this? Well, we know intuitively, but I want to kind of frame it within a model. There are those that have worked on models of what are called intelligent civilization theories. And the bottom line of these intelligent civilization theories is that any intelligent civilization, and again, I want to go back to the point that if intelligence is part of the fabric of the universe, life then should evolve over time, if it can survive, into a high degree of intelligence. So I wanted to kind of draw that connection. But intelligent civilization theory basically makes the argument that any intelligent civilization is going to be ultimately driven by the need for resources and energy, because that civilization is going to unlock the scientific understanding and going to develop technology that's going to drive the need. The only way to evolve, in other words, is on the basis of additional resources and energy that grows what we've seen, at least since the rise of the Industrial Revolution, that can grow exponentially over time. They talk about different types of civilization. A type 1 civilization is very much one that's, I think, falls within the realm of a disconnected worldview. The idea being that we are confined to planet Earth, and you really don't think much beyond planet Earth, and that's a type 1 civilization. And then you look for the resources and energy within that contained biosphere. Well, that's a finite biosphere. Resources and energy only can go so far, although there may be some ways to better manage that. If we talk about renewables, nuclear fusion to a certain extent, although we need the nuclear fuel. But ultimately, it's a finite system. At one level or another, there's some finiteness to it, whatever kinds of energy system we're able to develop. So they talk about a path where you emerge from a type 1 to other types of civilizations, and I won't go into all the types, but ultimately they expanded out. Some of the folks who have developed those theories and models talk about type 4, type 5 civilizations that are galactic and cosmic. But a type 2, just to simplify it, a type 2 civilization, moving to the next level, is a civilization that's spacefaring. Now, we began to shift away from a type 1, moving in the direction of a type 2 with the rise of the space age. Most scientists who've studied this and look at this model are of the view that we're somewhere between 1.5, 1.6, 1.7, depending on who you look at, in terms of that 1 to 2 scale, that we're not quite at the type 2 civilization, which is truly a spacefaring civilization. So I think ultimately we need a civilizational shift in our thought process. And I think that's enabled by the Earthrise image, right? The image of the Earth from outer space, the overview effect, by thinking about the connected worldview. That's enabled by postulating and exploring a unified scientific framework. I mean, it has many, many various aspects to that, but postulating that and trying to move forward in that direction in the scientific enterprise would also allow for this. Would allow us truly to become more of a spacefaring civilization to avoid this potential global extinction event that we're facing with human-induced climate change, allowing us to think about our resources and energy in a fundamentally different way, to think about it off Earth, instead of exploiting the planet, continuing to exploit the planet in such a way that causes global climate change, human-induced global climate change, think about it off Earth. And I think ultimately that's one of the great implications, positive implications, that can benefit humanity. You know, if the argument is we want to perpetuate the human species, if that is the argument, that's the postulate, thinking off Earth can allow us to, I think, optimize and deal and address this problem that we're facing, given that we're going to always be driven by the need for resources and energy. So how do we manifest this? And I think we're seeing elements of that beginning to occur. Many of us in the space community are attuned to this argument and this insight. And I think if we begin to look at the spacefaring revolution that's going on as I'm talking, this is the beginning of the manifestation of moving and becoming that type 2 civilization, becoming that spacefaring civilization. We can look to the lunar surface. I know people like Dr. Bernard Foying, who's on the call, on the talk, listening in, has done a lot of work in this direction, and others. We're talking about lunar mining. On the surface of the moon, we can mine valuable lunar resources to not only self-sustain a lunar colony in whatever form that may take. You know, I think initially probably we're looking at, you know, a scientific base, but that's going to evolve into what's called in situ resource utilization and mining lunar resources for building infrastructure on the moon. We know in the cold trap regions, particularly in the Aitken Basin and the southern polar regions of the moon, there are cold traps that never receive sunlight, of frozen water ice. Yes, embedded with lunar regolith, though, you know, we have mining processes and techniques that could capture that water, and that's a source of that's a source for fuel, a source for growing, you know, growing life in ecosystems, artificial ecosystems. But we can also look to the moon beyond all that. We can also look at the lunar surface as one example of materials that could support a future energy system for Earth, such as fusion. If we think about deuterium or helium-3 as two viable energy resources, we know that on the lunar surface, there is an abundance of these type of materials that can be mined and used for nuclear fusion reactions, as an example. Others have talked about mining asteroids. You know, today we have geopolitical conflict and struggles that I think tie in different ways to the space domain, because we're using the space domain. You know, we've militarized space, right? And there's a military space area, and we have military space forces that are proliferating worldwide, and there's global partnerships between those. I mean, I get exposed to this every year at the National Space Symposium, and that supports, you know, our capacity for war fighting on planet Earth and greatly enhances our capacity for engaging in terrestrial conflict. And part of that conflict is won over, not much talked about, over rare earth materials, rare earth resources, platinum group metals. And this exists in abundance within asteroids. So there are concepts and ideas regarding, the mining of asteroids. There are other concepts that I've been involved with in workshops in my time in the past. There was a very, very interesting workshop I was involved with when I was a professor at the U.S. Air Force Academy. And this was involved with the Department of Defense of the United States, where they are very, very interested in how can we more optimally provide energy that we need for forward deployment operations. Logistically, that's very, very demanding, because when you go into forward deployment, you need to carry self-sustaining energy systems. Very, very difficult to provide the energy needed for these military operations. And they tasked us with, well, why don't we look at space-based solar power? And this is an idea that goes back to the 60s and 70s. There have been multiple NASA studies. The Europeans have studied this. Other countries have studied this. I think the Japanese have flown even an experimental satellite. The idea being that we can create large-scale solar power stations, infrastructure in space on a 24/7 basis to capture the sun's energy and then to beam that back to Earth. Wireless power transmission, we're on the cusp of being able to master that today. And using wireless power transmission to bring that energy back to planet Earth. So these are some concepts we can think about in terms of how space can begin to support the resources and energy we need. And if we can further unlock the secrets of the universe, there is that potential postulate of infinite energy being locked into the fabric of the universe that can be there for the taking. Obviously, we're not there yet, but I think that's an interesting insight and postulate. One other idea that I'll just put forward, and there are many, many others you can discuss, is off-Earth industrial processing. So if we begin to think about industrial processing, mining in outer space, we can then begin to take these activities off planet Earth, move towards more sustainable development practices more optimally by ceasing at least the majority of the extractive ways in which we go about acquiring resources to produce energy and moving that off Earth. I think this epitomizes, in more ways than others, what it would imply and mean to be a spacefaring civilization. Beyond people living off planet Earth, which is another area or proposition. But ultimately, the most optimal biosphere for us is planet Earth, right? As a great of adventure as it sounds, living on the Moon or Mars, which I think will occur in the future, is much more daunting, right? We have to be always in artificial ecosystems, whether in our infrastructure or in our spacesuits. We don't have an optimal biosphere outside of planet Earth, at least that we can reach, right? There are potentially extrasolar planets, but the most viable ones are light years and light years away. I mean, the closest one would be in the Alpha Centauri system, which is over 4 light years away from us. To quote my late father, since he was brought up and I mentioned, my late father said, any civilization that does not challenge the impossible is doomed to fail. And the impossible today is the exploration and development of outer space. Ultimately, and I just want to draw quickly on quantum physics, and there's some interesting work going on in terms of how the quantum physicist insight, the insight that we have of quantum physics can shift our perspective to a connected worldview. And one of the most interesting insights that I just wanted to draw on is that all realities are possible, okay? So there's this idea that physicists are beginning to understand that in the quantum world, everything is possible. And what we call reality is simply a collapse of one possibility at one point in time when there is an observation or interaction. And this is really, really interesting. This has been shown experimentally, that once we observe and interact, there seems to be a collapse of a certain reality that we can then observe, that then begins to manifest. So this really suggests that, you know, all realities are possible. It's really up to us to interact with our environment in such a way that allows us to sustain and advance ourselves in ways that I think are more harmonious and sustainable, which also I think draws on other forms of knowledge, you know, that I really haven't discussed today. But I think it's important to realize that as a modern society, we tend to default to a scientific way of thinking on all matters. And there's nothing wrong with that. The scientific methodology and process is extremely powerful, and there's no questioning that. My thought here is that we shouldn't, as a result of that, we shouldn't ignore or diminish how other knowledge systems can also be of benefit to us, such as indigenous knowledge or spiritual knowledge. And if you look at indigenous knowledge systems and spiritual knowledge systems, both of those knowledge systems have understood for thousands and thousands of years, as they have developed and evolved, that there is a connected worldview. And I think if science was better informed from these knowledge systems, it would allow science to accelerate that shift, which I think we're the beginnings of it, but it would accelerate that shift into the connected worldview, which I think is epitomized by us being spacefaring and us emerging as a type 2 civilization. Okay, I'll conclude there. That went on a little longer than I thought, so that was about an hour. So we'll open it up for questions. And I did bring in some astropolitics, but I thought I would do it in a refreshing and unique way instead of the standard, you know, here's the political model, here are the geopolitical dynamics. But I'm happy to discuss any of those dynamics if people are interested in the geopolitics. As I mentioned, I just was at the Space Symposium in Colorado Springs, where basically the commercial and governmental leadership of the world is there. A lot of military space folks as well. Was interesting. I attend that meeting every year. It's in my backyard here, about 2 hours from now.
Yeah, it is.
So good. Well, let's open it up. Yeah, love to have some discussion.
So thank you very much for this interesting lecture. We have a lot of comments and in the chat. I would like to welcome also people from Spain, from Virginia, from Planet Reunion, from the United States MD, and and from Spain, Barcelona. Hello. So we have questions here. Also, thank you again. It was really, really amazing. Moment. Eirik Isen, I don't know if you know him. He writes, the rights of nature should be established here and learn sustainable mining. Maybe space mining could be the example. It's more remarks, but here's a question. If rover tracks are considered megalithic memorial sites subjects to space law, imagine the red tape of the moon base. Can we possibly leave no trace? And if not leave, and if not leave it better? Do you understand what I was? That we don't leave
kind
traces?
of. I mean, well, you mentioned, is this like, well, there's one thing that I heard in there was you have the preservation of landmarks on the lunar surface, such as the Apollo, the Apollo landers that remain there. Some of the robots that have landed onto the surface, the rovers. I know there's talk about a preservation of that, but I think the way I understand the question, I think it really gets into, and Bernard knows a lot about this as well, probably a lot more than I do, but I've been exposed to quite a bit of this, is planetary protection and planetary protection policies.
Yes.
We have what's called forward contamination and backward contamination issues. And COPIUS has dealt with this. COSPAR has dealt with this. COSPAR, in fact, has Committee on Space Research, the global committee of scientists involved with that, the global community of scientists, have established guidelines on planetary protection policies, which actually is part of astropolitics. So I know some about this. And the question really is more about the forward contamination issue. So they'll classify planets based on possibilities for past or present biology. And planetary surfaces, planetary bodies that have a higher, there's a greater degree of evidence for past or present biology, any kind of biological processes. Some of this, I think, ties into some of the chemistry as well, because, without the right chemistry, you don't get biology, right? I mean, in the world of science, we always joke physics defines the reality for us, and then we have chemistry, right? But you really don't have any physics without chemistry, and you can't have any life. Life can't form without any chemistry either, right?
Yes.
But I think the issue of the moon, obviously, on a place like Mars has a higher. The evidence supports the hypothesis that there was past life on Mars, probably current life, although there hasn't been a positive detection. There's been some debates. We had the Allen Hills meteorite debate that was ongoing, that's still ongoing, whether that was evidence of microscopic life. There's been some interesting evidence from the rovers. Nothing that I have seen that suggests a high degree of confirmation as of yet, although we're very close to that, I think. So Mars would have a higher status of planetary protection, and how those guidelines then would guide our activities on the planet, whether robotic or humans. On the moon, there's less of a concern because the moon is looked at as, at least in terms of biology, we know it's a dead body for the most part, but there are valuable lunar resources at the same time. So I'm not sure, I'm not completely abreast of the current thinking in regard to the moon, particularly given the Artemis program right now, the Artemis Accords, and then the International Lunar Research Station program with the Chinese and the Russians. We are going back to the lunar surface within the next year or two, probably with Artemis. By 2030, there are going to be people inhabiting the moon on a permanent basis. What are going to be the planetary protection guidelines? And this also ties into broader issues of what are going to be our codes of conduct on the lunar surface. We did have the Moon Agreement, although the Moon Agreement is really not from most legal experts, it's not seen as a valid legal instrument to guide our activities because no spacefaring states have ratified it. France and India signed it, did not ratify. No other powerful spacefaring state has supported it. It doesn't have universal adherence like the Outer Space Treaty and its associated treaties that further elaborated some of those principles. So that's still pending. What are our codes of conduct? What are planetary protection policies? People have talked about safety zones, principles of non-interference, which come out of the Outer Space Treaty. How will that manifest into preserving the lunar surface? Are we going to bring forward, part of the interesting thing in the question is, are we going to bring forward environmental principles we've established here on planet Earth? I love going into nature. I live in the high Rockies of Colorado. I have, I'm looking out my window here at 4,000-meter mountain, and we have policies out here of what's called leave no trace, as was mentioned. Should we imply, these policies of either conservation or habitat protection, environmental protection, should that be applied to outer space and places like the lunar surface? You know, so I think there are many, many interesting dynamics and issues that we can debate on that.
Can you show us your mountains?
Oh, sure. Yeah, I have a big mountain here.
Ah. Oh, wow.
Wow, fantastic view. Wow.
Yeah.
Here's
Like
another
the
question.
Alps. I live like a place like Chamonix, you know, that's what.
Yeah, exactly. Mont
It's
Blanc.
really amazing. The other question is, if we were to terraform Mars, also in case, yeah, would we possibly interrupting a natural evolution of life unknown to our timescale perception? Interesting question.
Well, it's an interesting question. You know, it's quite futuristic, you know, whether we can terraform a planetary body. I think in some ways we are inadvertently doing that to we're terraforming planet Earth, right, with global climate change, human-induced global climate change in different ways. The capacity to do it on a planetary scale we're not there as of yet. I don't think it's beyond conceptualizing that humanity will get there at some point, but it poses really an interesting question. I think it goes back to some of the things I just discussed. You know, do we have the right to do that? You know, some have made the argument that we need to keep the universe in the environmental state in which we found it. That leads to a policy of environmental protection. We have that to one extent or another on planet Earth with limited use capacity, such as national park systems, whether in the US it's quite prevalent. It's been developed in other countries, not quite as common in Europe, but we've seen it like in Chile. The idea being is you take a beautiful part of the planetary body and you preserve it as best as possible. Or do we have the right of commercial use? Do we have the right to exploit? Do we have the right to alter the environment based on human needs? And I think part of it too goes to the question of, are we going to be solely driven by an anthropocentric view and model? Or are we going to evolve out of that? I didn't discuss that too much in my talk, but I think that's one of the implications. If we remain anthropocentric, that is a certain consequence. But if we begin to think in a way that is beyond the individual human being, beyond our self-interest, that has a different consequence. So I think that all ties into, you know, this whole terraforming debate. You know, and these are political questions. These are questions of ethics and values that underlie the way in which we should or should not behave. You know, and I think we are today struggling. You know, I mentioned this, you know, like Adriano mentioned, how you feeling? And I said, I'm not feeling great about the politics of the US right now, but we're struggling, I think, with what should be our underlying value system and ethics that drives human activity. And if we talk about it in the context of astropolitics specifically, that translates into things like planetary protection policies, codes of conduct, principles of the Outer Space Treaty. We have a framework. Tied within that framework are underlying assumptions, right? Betterment of the human species, betterment of planet Earth, peaceful uses, protecting planetary bodies to one extent or another, having codes of conduct that are cooperative and collaborative and not contesting, conflictual, warfighting, etc. in the space domain. So that has real consequences if we think about it through the lens of astropolitics.
Yes, but I think that is a planetary protection, and what you mentioned is a contradiction to the mining of not only asteroids. The asteroids, okay, no problem, but people are going to the moon to do something there. They want to construct habitats. They want use it as a base to go to Mars, but they also want to mine on the moon. And okay, we know there's no life on the moon, but we are changing the surface, and the moon is not so far from Earth. You can see it without telescope, and you can see some structures without telescope. So maybe the surface will change that way, that it's for us unrecognizable or whatever. Yeah, and in some cultures, the moon has a special meaning. So yeah.
No, it's a good point. Yeah. I mean, clearly, yeah, I'm talking about the range of approaches and insights. Yeah, but that's a good point. Yeah.
I would like to say something. If okay, of course, this was such a big piece of philosophical discussion, very, very interesting, and there would be tens, let's say tens, not to say hundreds of discussions to be developed. But however, since the discussion in the last 10 minutes was oriented to what could be the best model for an extraterrestrial living in space. Well, first of all, I am a humanist, or even if in this last months, my humanist convictions are seriously shocked by what is happening in the world. However, okay, this is another discussion that I don't want to start now. However, I think that the best model about starting to move outside, because I think a type 2 civilization is not a civilization that remain on Earth and go sometime in space to take things and bring it back to Earth. A type 2 civilization is an expanding civilization into the solar system. So the main point is where are we going to live and work and stay for undetermined time? Where will we migrate in space? Well, I think the best answer was given in 1969 by the students of Dr. Gerard O'Neill, to which O'Neill asked, do you think that a planetary surface is the best place where to live outside Earth? And the students replied, no, it is not, because the gravity is not the same of Earth. So that would mean that very serious changes, biological changes, will occur in a very short time. So that's a limitation. This is my further elaboration. That's a big limitation to the freedom, because we also have to think that an immigrant could maybe decide one day to come back to Earth. And if he stay on the moon, for instance, for 3 or 4 years, he will not come back to Earth if not on a barrel, you know, because cannot stand the gravity of Earth. So we have to think about humans, first of all, humans' requirements that are biological, health, reproduction, and freedom. Most of all, freedom. I want to have to be free to go where I like to go, and also to come back. So currently, the only really pragmatic and I think pragmatic plan more need the human requirements is the Jeff Bezos plan. That is the O'Neill plan, so we can call it Bezos O'Neill if we like. That is planning to move the industrial development outside Earth in the cislunar space, and to that we can add to decrease the energy demand on Earth, because now we have energy demand on Earth is very much rising because of the new technologies, artificial intelligence, electronic money, electrical mobility, and the energy demand is rising, skyrocketing. So what can we do? Simple. we have to start moving outside. We have to start, for instance, putting in orbit the big data farms, feeding them by the sun, right? The sun power. Sun power should be used for space, not for Earth, because the right direction to follow the Kardashev evolution is to expand, not to bring more energy on Earth. That will only raise the pressure inside our planet. It's something to avoid, because we have already too much pressure on this in the ecosphere. So we have to start moving, and also I think last. Then I stop.
Yes, I wanted to...
because I have too many comments. Well, I think that when you talk about the risk to have a militarization of space, a weaponization, and so on, always let's think that overview effect exists, and even if the big leaders on Earth will command their space force to go there and fight, you cannot be sure that when the soldiers will be there, they will really fight. Because I think space, to be in space, will maybe stimulate the birth of a new romanticism and of a new brothership. There's something like what exists in the sailors, in the marinery. Because if you see somebody sinking in the sea, it doesn't matter what is the nationality. You go there and save and rescue. And this thing in space will be multiplied for many exponents, you know. So I think that going outside, we will become more human than what we are now. And yes, this is as a humanist, this is my hope. And it is what we have to fight for now, I think. Okay, sorry,
Yes.
it was too long.
Bernard, you wanted to add something too, or do you have a question? You have
yes, maybe a question, not only a monologue, but okay, I think Adriano's point are interesting, even though, okay, maybe a bit a dream. I think that what I appreciate is your view of astropolitics is guided by universal values, Eligar. So rationalism and overview effect, the awareness, okay, of the evolution, climate change on Earth. So all those aspects clearly are based on science and so on. But now, how does astropolitics get along with geopolitics? Because anywhere at this Space Foundation conference, and do you see now that the different countries, also the commercial world, the military world, do not they diverge from this universal vision of exploring space for science or exploring space for society? So how do you see now that the different countries, in fact, diverge from this more idealistic vision, like the one of Adriano?
Right. Well, thank you for the comments and insights and question, Adriano and Bernard. I think that's a great question. You know, I think it's complex and it's multivariate. You know, there's a range of things that you see that are going on. It's not one thing or the other. You know, I think on one hand, there's an understanding in the commercial world and in government space that we need to have a sustainable use of the space domain, right? And I think what Adriano was getting to, which I think is very important, is, you know, he's talking about the forward-looking dimension off Earth, right? Which really wasn't as much the focus of what I was talking about, which is how we're going to become spacefaring and live off Earth, whether it's in orbital environments, like Jared O'Neill's concept, Lagrange points between the Earth Moon system, lunar surface, Mars, maybe one of the moons, right? One of the moons of Jupiter or Saturn. Who knows? We're exploring some of these interesting moons, although a much harsher environment when you think about Europa or Titan, where there's potentiality for life to exist. But there are some places close by, right? Moon and Mars are close by in our solar system. So that's one aspect of it. The aspect more I was talking about was, how in becoming spacefaring, that we shouldn't disregard the value that it brings back to Earth, right? The value that it brings back to our home planet in the biosphere here. But I think in terms of, the geopolitics, again, it's varied. There's the emphasis on the sustainable uses of the space domain because of the value it provides, the value-added services in terms of data, intelligence gathering, weather forecasting, monitoring of the habitat, etc., of the interesting science and data we can gather on other planetary bodies. We're talking about the space telescopes, cosmological processes, etc. All that advances us as a human species in different ways. We can argue how and what, if that's good or bad, but there is that. It does tie into intelligent civilization theory. So I think there's that understanding that we don't want to undermine that. So I think you're seeing a mixed policy position. One being, we want to avoid and mitigate orbital debris, for example, which is a problem because space was largely set up as a commons. When you have a tragedy of the commons and the orbital debris issue. And they want to mitigate that. You have commercial entities now that are collaborating and sharing data to prevent conjunctions in the orbital domains. There's an understanding that we are on a path of an unsustainable use of the different orbital domains that can undermine things. The ITU has established, geoslot designations into the ITU Constitution Convention, which governs the way in which international telecommunications satellite providers can position their satellites with associated footprint on Earth for telecommunications purposes. So I think we have elements of governance, and I think that's what you're getting at, Bernard, that there are some that think we have no governance, which is not true. And I heard this at the conference, and I almost was like ready to shout out and say, no, you're misunderstanding it. But we don't have an optimal system of governance. And then if we begin to talk about governance in the space domain, well, what does that mean? How do we structure that? What's the value system? What Adriano talked about, I think, is a strategic hope that you can interpret from the Outer Space Treaty, that we want space to be there on a human level as a humanist. I'm also a humanist. We want space to be there for the betterment of us as a species, whether we live off Earth or whether space benefits us on Earth, for collaboration and cooperation, for innovation, for the gathering of data and science that can benefit us. I think there's that desire, but at the same time, there's the geopolitics, and there's the understanding that what the US and its allies do are going to be countered by China. And if there's a terrestrial conflict, we've militarized space from day one. Space has always been militarized. We use it as a domain, a more passive domain, because we're not fighting wars in space as of yet, to gather the data or to support precise locations on the planet for warfighting purposes. And there's as well the geopolitics of a different perspective that ties in the current geopolitics of the world. And I think we're locked into a Cold War today as we were in the 1960s. At the Space Symposium, you have the military leaders saying, yes, we want the peaceful uses of outer space. We don't want war in space, but China's going to contest us. China's our adversary. We're going to partner with our European allies, and the Europeans are on board with this, and Japan, and New Zealand, and Australia, and certain African countries. They were all there at the Space Symposium. the U.S. Space Force initiated a global partnership program to better tie together the Space Force capabilities. It's not a very advanced level as of yet. It's more the sharing of information and data. But I could see that evolving something like into a systems of systems approach that we've seen in the Earth observation arena. And that wouldn't be good for some of the visions we're talking about here, what Adriano was talking about. That would undermine, I think, the Outer Space Treaty and the principles therein, could undermine attempts at more effective space governance. It will undermine the sustainable uses of the orbital domain, could so dramatically alter the space environment that we could not proceed, at least in the near term, with the space enterprise as we have proceeded. So it's mixed, it's complex. I think how it will play out, it's hard to know, but I think ultimately you can't escape the geopolitics, unfortunately, So.
Yeah.
I think orbital debris
I would
richness,
add
richness too. The lesson for debris is the same we have to learn on Earth. If the waste can be processed and transformed into energy and new material, the same thing we have to do in orbit.
Yeah.
That will start the orbital industrialization. It's very important.
Adriano, there are space companies doing this already. I can't remember.
Yeah.
I saw two companies at the symposium. I can't remember their names right now that are developing systems that do exactly this, to recycle and reuse. I think that's what I'm saying. It's an interesting dynamic. I think fundamentally, I think the consensus is that we don't want to ignore geopolitics, because that's how the world plays itself out in the international system. But we all understand that we have more to gain by adhering at least to the basic tenets of the Outer Space Treaty as a overarching governance model, because we need the sustainable use of the space domain. And if we don't have the sustainable use of the space domain, all the value that we're getting from that domain will be undermined. So I think that's largely a consensus among the commercial, the military, and the civil space sectors. But competition, conflict, geopolitics, it all gets in the way of that. And we may be our own worst enemies in different ways, right? As humans, we're an interesting species, to say the least.
Here's a nice remark from Eirik Isam. We return to the care of nature through the process of becoming native to the cosmos. It's true. And Ronnie Lieberman is asking how to diffuse the space race and promote cooperation.
Well, that's a good question. I think I'll just share an interesting story. So when I was at the Air Force Academy, I was involved in a diplomatic dialogue with the Chinese for 3 years. This was not sanctioned by the US government, but since we were at an academic institution, although it's a military, Air Force Academy, it's the military institution of the Air Force. It's an academic environment as well. It's a university. We were able to engage in what's called a 1.5 diplomatic track. So a one diplomatic track is official government to government. Diplomacy 2.0 is non-governmental. 1.5 is a hybrid where you have government officials not representing the government or their positions in government, but attending the meeting and expressing their own views and insights. But that has implications, right? Because they can go back and try to change government views. And we were engaged in an interesting dialogue with the Chinese. And I think there was, just to give this example here, we need to be engaging with others and not to discount other cultures, other value systems, other national interests that may exist, because that's just going to be part of the makeup of the world. We're drawn up into over 200 states throughout the world. There's different civilizational breakdowns that social scientists have analyzed that the world's broken into. And the Chinese in the 80s and 90s were fully committed to engage with the Western world, particularly the United States. And for various national security reasons that I don't want to get into, I mean, I just don't have time for it, the US did not engage the Chinese at that level. And they always viewed the Chinese with a high degree of suspicion, particularly in any kind of strategic engagement. Has geopolitical factors to it, but we also discovered linguistic factors, cultural factors, ideological factors that didn't allow that bridge to merge. And as a result of that, the Chinese, being proud of their own long culture and history, said, we're just going to do it alone. You know, if the Western world doesn't want to collaborate with us at the level we want to collaborate, we'll just do it alone, and we'll find other ways to move forward. And then they've done that. And that has intensified the geopolitical dynamic, right? This dialogue I was engaged in was from 2007 to 2010. At the end of that dialogue is kind of the beginnings of the Cold War space race that we're currently in. And I think it's that if we want to avoid this geopolitical dynamic that ultimately leads to contesting in space, I think that's the most problematic. Some competition can be healthy. You can make an argument for or against that, but there are healthy forms of competition. There's unhealthy forms, but contesting is not a great value system, right? When you begin to contest, it's war fighting, it's conflict. It's not advancing us in necessarily positive ways as an entire human species. And I think that began to underlie this contested scenario. And then we begin to build narratives. I talked about that earlier. Narratives that justify our national interests, right? Oh, space is contested. Oh, space is a war-fighting domain. Although in reality, most of what we do in space is not contested. Most of what we do in space is not fighting wars in space, right? Most of what we do is probably peaceful and collaborative most of the time. Although, you know, there is that aspect of using space to support terrestrial warfighting, but we're not fighting those wars in the orbital domain, in outer space itself. So I think it's an interesting question. I think a lot of it has to do with what I went back to earlier at the beginning of my talk with the overview effect. We need to change the paradigm. Our worldview fundamentally needs to change.
Yeah.
The more we understand we're connected, the less we're going to contest and conflict and fight each other. So we need that. We need a paradigm shift. You know, Thomas Kuhn wrote about that in his book on paradigm shifts. You know, seminal study from the 1960s, and we need a paradigm shift ultimately to get away from this contesting of the space domain that's going on right now.
I believe the biggest risk, yeah, just short. The biggest risk we are running is to look at space using our narrow view that we have on Earth. We have to think about the universe. Howard Bloom, I think you know him, is coming up with a new book that will be very interesting. He just asked me to write a short piece of appreciation for that. And the title is The Sexual Cosmos. And he says a very interesting thing, that the cosmos is working on abundance. Yeah. Is a flamboyant cosmos. Is not a Ebenezer Scrooge, not counting each cent. No. Cosmos is spending.
Yeah, but okay, that's a poetic, but I think that's a reality also.
Yes, but it is a good point of view, because we have to start thinking in terms of abundance, any more of economy, but ecotrophy.
But yes, space is also hard.
The big
hard to live there. But, yeah.
Okay.
But in any case, we have our change of paradigm. We propose space renaissance for all.
Yes.
Yes.
And that's also where we share some of the benefits also with emerging countries. We inspire minds, we inspire the next generation, and also gives them this awareness of our Earth, our spaceship, and as well what we have to do to protect the Earth, but as well, yeah, you mentioned, is universe a natural park? To the difference that maybe, you know, because life is maybe unique to Earth, a value of bringing life beyond Earth is important. So bringing life to the moon and other places where there is no other life. So that could be a very important mission. And in that case, it's not only humans, it's also our biosphere that we could bring along.
Of course, yes.
But
So,
space resonance for all is what we propose. Then
yes,
join the movement. Yes.
yes.
Yeah. Okay.
I would
I'll
like
try to be more active too. I'd love to be more active with
Oh
the.
yeah. So yes, join the Space SDG 18 and Space Renaissance for All. We are
Yeah.
going also to launch a payload celebrating Space Renaissance for All in June. Together with the Expression Company, we will launch a gallery in space that will include some scientific samples, some artistic samples, including from Sabina, some music from Adriano, and but also we'll launch some tribute to some of the space organizations. So we launch that in orbit, free orbit, and bring it back in a cargo. And so we hope to celebrate that in June. We launched from Vandenberg base with SpaceX,
Oh, nice.
and we try also in the future always to mix not only the technical aspect of space, but also the artistic, humanistic, and also the social benefit of space for all.
Yeah.
thank
Well,
you.
great and
So,
wonderful.
Great. I think we are at the end.
Eligar, I would like to thank you very much for your interesting lecture, for the very nice discussion we had also in the chat. Maybe you look after this. I also would like to invite you to become member of SRI. We have an academy. We have many.
I think he already is. Aren't you? Aren't you?
I think I might have. Let me check if I'm
Yeah,
currently. I have to
but
check.
also bring your students.
Maybe
Yes.
you're a
Bring
member
your
of.
students here.
And my students as well. That's right.
And to all people who are listening, we are a non-profit organization, so we would appreciate your support. And I would like to invite you, also you, Eligar, to our next webinar. It will be on April 21st, and Aldo Spadoni will talk. I don't know if you know him. He's very well known as a space artist. And yeah, I'm really lucky or happy that he will join us. And thank you again for being here with us, for your knowledge, your
Of course,
support.
my pleasure. Yeah.
Thank
This
you.
was a pleasure for us. And to everyone on the screens, thank you for joining us. And I wish you all a nice evening, a nice week. And I hope to see you in 2 weeks more.
Thank
Sounds
you.
good.
Okay,
Thank
ad
you.
asta.
Goodbye.
Bye.
Bye-bye.